Hello to everyone, welcome once more to another video in this YouTube channel. So in this video we are going to be looking at June 2022 Pure Maths with Mechanics paper 2, question number 2. Okay, we are going to solve Roman 1 of the equation, and then now in a subsequent video we are going to complete Roman 2. So Roman 1 reads: a function f defined from arrow minus 1 to arrow minus, from arrow minus negative 1 to arrow minus 1 is defined by f of x equal to x minus 1 divided by x plus 1. A. Show that f is surjective. B. Find a composite function f of x stating its domain. C. Determine whether f of x is an even or an odd function. So it's allocated for 3 and 2 marks. That's a total of 8 marks. Okay, so before I start with the solution, I would first of all like to display to you guys basically what the definition of the function in this situation means. All right, so generally if I have a function, let's say I have f, which is a function that's from a right up to b. Now this reads as f is a function that maps element from the set A to the set B. The set A is called the domain and the set B is called the codomain. Now if this is a function, it means that all elements that are in the set A will have one and only one image, which is found in the set B. So maybe I can give you a little representation. Here's my set A, and then here you have the set B. Okay, so if I have an element that x is here and then now the image is y, x relates with y by the function f. So if I take f of x is called the input, and then I'm going to get y is called the output. So also another element, maybe I can call it x1, can also have the same image, but the thing is that any element that is found in the set A will have one and only one image in the set B. That's we have one and only one image. So a function is either a one-to-one relation or a one-to-many relation, because this element x1 here can also have the image as y. So f of x1 can also be equal to y without any problem. For example, if I have a function f of x equal to x squared, you see that f of negative 1 is equal to negative 1 squared, which is 1. What about f of 1? F of 1 is equal to squared, which is 1. So you see that the two elements negative 1 and 1 are in the domain of the function, because this function f of x is defined this way: arrow to arrow plus. Arrow is a domain and then arrow plus is a range, meaning where it lies. It is always positive, lies above the x-axis. So I see that I have two different elements here, but at the end they have the same image. So that is a many-to-one relation. Now in terms of one-to-one relation, let me just say, for example, f of x equal to x. You see that f of 1 is equal to 1, f of negative 1 is equal to negative 1. So but if now I give you f of x equal to negative 1 plus or minus the square root of x, this is not the function again. Why? Because if I take f of 1, for example, I'm going to get negative 1 plus or minus the square root of 1, which is negative 1 plus or minus 1. So it is either negative 1 plus 1 0 or negative 1 minus 1 negative 2. So we see that an element in the domain of definition has two different images. It is not a function. We now call it a mapping. Okay, now let's get back to our equation. We are showing that the function is surjective, right? What is a surjective function, or how do we show that a function is surjective? Now the basic definition of a surjective function is that if I have for every element that, let's just say every element x that belongs to the domain of definition of my function, in this case I can call the domain A, there exists an element y that belongs to the codomain such that f of x is equal to y. That's the basic definition of a function which is surjective. If f is surjective, then this property holds. All right, so here, for us to prove that our function f of x, now our function f in this case is mapped from, here is it, arrow minus -1, meaning that this is a domain, to arrow -1, this is a range. Sorry, this is a codomain. Yes, or the range, that's the domain of the inverse. So arrow minus -1 to arrow -1. Okay, so the function in this case is f of x equal to, our function is f of x equal to x minus 1 divided by x plus 1. All right, so let me just try to display to you guys what I'm doing. Okay, so for us to show that the function is surjective, what do we need to show? We need to show that we need to show that the range of my function f is equal to the codomain. Okay, now this my function f, so this is the domain, this is the codomain as per our explanation. Now what is the range? The range is simply the domain of the inverse. So the domain of the inverse should be equal to the codomain. Now my codomain is the set of real numbers minus 1. So all values of x in the set of real numbers minus 1, that's my codomain. Now I need to find the domain of the inverse, and then later on, after finding the domain of the inverse, and I'll use it to find the range. Okay, so how do I get the inverse? I start by letting y to be equal to f of x. Even per my definition, we see that y will be equal to f of x. Okay, so this means that y will be equal to x minus 1 divided by x plus 1. So I cross multiply, I'm going to get yx plus y is equal to x minus 1. I look for the value of x. So yx minus x is equal to -1 minus y. So it means so this means that x into y minus 1 is equal to -1 minus y. So it means x is equal to -1 minus y divided by y minus 1. So you can divide by the negative and we get y plus 1 divided by 1 minus y. But since my function, we see that y is equal to f of x, it means that x is equal to f inverse of y. So here x is equal to f inverse of y, here x is equal to y plus 1 over 1 minus y. So what does it mean? It means that f inverse of y is equal to y plus 1 over 1 minus y, clearly. So since x and y are variables, what does it mean? It means that my f inverse of x will be equal to x plus 1 divided by 1 minus x. And what's the domain? The domain of my inverse, domain of f inverse of x is, now this is a rational function, right? And that's a rational function, and for it to be defined, its denominator should be different from 0, provided all the other functions are already defined. So clearly 1 minus x is different from 0, meaning that x is different from 1 to get the domain of definition of my function f inverse of x. So it means the domain of f inverse of x is x in a set of real numbers excluding 1. Alright, so since our codomain, here is the domain of the inverse, which is the range. So all of this, we call it the range. Okay, so the range is x in the set of real numbers excluding 1. Now if you come to our codomain that was given, you see the function was defined in this way. The codomain is the set of real numbers excluding 1. So the two are the same, so we can conclude that the function is surjective.